to this video series called Web Automation with Lambda Test and PyTest. My name is Carlos Kidman, and I'll be your guide as we create web automated tests using Python with PyTest and hook it up to Lambda Test, which has lots of awesome features like reporting and logs, storing video recordings of our tests, and making cross-browser testing super easy. In this course, there are 5 modules. We're starting off with the course introduction, which is where you're at right now. Then we'll set up a Python project where we'll use VS Code to get a project ready for automation. We'll then write our UI tests where we'll create our first automated tests with Python and PyTest. Then we'll get those same tests and run them in parallel. And finally, cross-browser testing with Lambda Test, where we'll run our tests across multiple OSs and browsers using Lambda Test. Alright, so what is Lambda Test? And why does it matter? Lambda Test is a cross-browser testing solution that is done entirely on the cloud. If you need to perform any human-centric or exploratory testing on a specific version of Windows or Mac, you can easily select the configuration and load your app in that environment. This also extends to automated testing, where we can write a single automated test and have it run against any number of operating systems and browsers to get the ultimate coverage of your application. This also includes mobile browsers. Say what? There's more features they provide, like geolocation testing and integrating with tools you're probably already using, so I'd highly recommend you check them out at lambdatest.com to find out more. However, we will be creating a free Lambda Test account in the last module, so you'll definitely get a taste of what it can do before the course is over. Now that we've talked about what Lambda Test is, now we can talk about why does it matter. Lambda Test solves a lot of problems that many of us face. First off, it solves the coverage problem. Without a solution like Lambda Test, you'd have to make sure all of the browsers are installed on your machine so you can test your application against each one. But if you're on a Mac and you need to test Internet Explorer, you have to get access to a Windows machine somehow. If you have an iPhone but you need to test against Android, you need to borrow someone else's phone or manage a device farm, which many of us know is time-consuming and frustrating. Lambda Test can spin up any OS and browser combination you need on the fly, so you can test what you want, against what you want, whenever you want. Which brings me to the next problem Lambda Test solves: reproducing these environments. If there is only one Android device for the team to use, then only one person can test at a time. All that waiting is wasteful. Lambda Test can spin up as many instances as you need, so your environment doesn't become a bottleneck anymore. Next up is the cross-browser problem in our automation. Time and time again, I see test automation frameworks that try to solve this problem on their own. They create a driver factory that tries to handle local and cloud executions, but it's not designed correctly and requires a lot of maintenance. In the end, it usually only works for Chrome and Firefox on desktops, and that's it. No mobile or Safari or anything else. With Lambda Test, you can extend your test automation to leverage all of the power and functionality that we've already discussed. So cross-browser testing, parallel executions, and more. All in all, this means that Lambda Test solves a lot of productivity problems because it already includes integrations, logging, reporting, recording, and more as part of its products and services. You wouldn't have to build this functionality from scratch and maintain it yourself. Instead, hook your framework to Lambda Test and get all of this functionality out of the box so you can focus on more important tasks. For me, that's one of the biggest reasons to use a tool like Lambda Test. And as you can see, in the end, that means that Lambda Test solves a lot of crap. I don't want to manage a device farm. That alone can be a full-time job, and it's not fun at all. Give me Lambda Test instead so I can focus on design, testability, and just writing the tests instead. In the next video, we'll get a Python project created and VS Code configured so we can start writing Python code. I'll also provide resources that you can use throughout this course since we're going to be in code for the rest of it. Real quick, before we move to the next module, I want to let you know of a few things that are available to you. please feel free to share your thoughts on this video in the comments below. If you have any questions around Lambda Test, you can either drop an email to support@lambdatest.com, or you could chat with one of their reps by pinging on their 24/7 chat support. Seriously, hit them up at any time with whatever questions you have, and they'll answer. If you're ever stuck with anything around testing, development, CI/CD, or whatever, then feel free to drop them in the Lambda Test community here at community.lambdatest.com, and they'll get your answers in no time. With that, I'll see you in the next video. Now that we know more about Lambda Test, it's time to set up our machine and project for Python development. I'll share a simplified version of my setup so you can follow along with me in the course. The main setup consists of Python version 3.8 or higher, Poetry, which is a package manager that I use instead of pip, and VS Code. Note, you are welcome to use your own setup, like using PyCharm as your IDE, for example. As for packages, the three main pieces are a virtual environment to manage dependencies, but Poetry handles this automatically. We'll be using Pylenium, which is a simple wrapper of Selenium with Cypress-like bindings, and PyTest, which is the test framework and is already included with Pylenium. Step 1 is to install Python and Poetry. There are a few ways to do this, but a manual installation should work just fine if you're starting out. So we'll install Python by going to python.org/downloads. The landing screen will look just like this with a button for you to download Python. Just click on that and follow the wizard and you should have Python set up. Once complete, you should be able to check your Python version by opening a terminal and running python -- version. For me, you can say I have 3.9.1. If you're on a Mac or Linux machine, you might need to say Python 3 -- version, since Macs come with Python already installed, but it's an old one like 2.7 that you don't want to use. Once you've confirmed that it's installed, the next thing for us to do is to install Poetry. And the way you do that is with pip install Poetry. But remember, if you needed to say Python 3 -- version, put the 3 right after pip. Pip 3 install Poetry instead. Once the installation is complete, you should be able to run Poetry -- version to see which version of Poetry you now have. Something like this is what you should expect. So, quick recap, you install Python and then you install Poetry. For step 2, we're going to install VS Code with the necessary extensions. So we're going to be downloading and installing VS Code by going to code.visualstudio.com/download. From there, we need to install a couple extensions. We need the Python extension and the Pylance extension. So let's go to that download page and download Visual Studio Code. All right, here we are, and kind of like how we did Python, this is their landing page. You can just click on this download. For me, I have a Mac, so it's showing me Mac Universal, but if you're on Windows, it'll say Windows here as well. Just click on that and follow the installation wizard, and once it's complete, you're ready to go. Now you can open VS Code so we can start installing these extensions. With VS Code open, on the left-hand side, you should see a bunch of icons. The one we care about is this one here, which is the Extensions Marketplace. Click on that, and there's a whole bunch of extensions that you can install. For now, the one that we care about is Python. And this first one here from Microsoft is the one I want. So I'm going to click on it and install it. Now, I already have it installed, so I won't, but you should see an install button right around here. Click on that, and it'll add it. It may ask for a reload. If it does, click yes and reload VS Code. We'll then do the same thing with Pylance. So search for Pylance, click on Pylance, and install it. And again, it should ask for a reload. But that's it for VS Code. So let's move on to step 3. For step 3, we just need to create the project and initialize it. So we're going to create a new project directory and then initialize it with Poetry. This is done by Poetry init, and then we can include the different packages we care about. In this case, it's going to be Pylenium, AutoPep8, and Flake8. Remember, PyTest we do want as well, but it's already included with Pylenium. Once the project is initialized, then we can install the packages, and Poetry will handle creating the virtual environment for us, which is really nice too. So to start things off, I'm going to open my terminal again, and we need to create this directory, or the new project. Now, I like to have a dev folder or a code folder and put stuff in there. So for now, I'm going to go into my code folder, and the CD just means change directory. So we're going to move into our code folder here, and then I'm going to make a directory, and let's call this one PyTest tutorial. And then from there, VS Code has a CLI command where you can say code and then put in the name of the project you want to open up. In my case, I'm going to open PyTest tutorial that I just created and press enter. And this will actually open up VS Code with the directory that I just opened, PyTest tutorial. By the way, you can also create new projects within the UI of VS Code. I just did it through the CLI because that's usually how I do things, but use the UI if you need to as well. Now that the project has been created and opened in VS Code, now we can initialize the project. I'm going to open my integrated terminal here, increase the size just a tad so everyone can see what I'm working with, and then run Poetry init. When you run this, it's going to guide you through this wizard. For now, I'm going to press enter on a lot of things. So the package name, the default is going to say PyTest tutorial. That's okay. The version, that's fine. Description, I don't need one. Yes, I'm the author. No license, please. 3.9 is fine. And then this one here says, would you like to define your main dependencies interactively? And I'm going to say yes, which is already the default. So I'm just going to press enter. The main one that we need is Pylenium. And so I'm going to search for Pylenium IO. And press enter. There's only one here, which is at position 0, so put in 0, press enter, and then it asks if I want to enter the version constraint for Pylenium IO. I don't, so I'm going to press enter again. We don't need any other packages, so I'm going to press enter one more time here, and now it's going to ask, would you like to define your development dependencies interactively? And I'm going to say yes here as well. This is where you can start including things that you're going to be using just for development. So in our case, I'm going to want a linter and a formatter. So for my formatter, I'm going to use AutoPep8, but there are many like black, for example. But AutoPep8 is the one I'm going to use. There's a bunch of different versions of it, but I want the first one here, 0. So AutoPep8. No version constraint, please. For the next package, I want to use Flake8, which is for linting. So Flake8. The first one is what I want, so 0, enter, and no version constraint. I'm not going to use any other dependencies here or any other packages, so I'm going to press enter one more time. And then it's going to say, hey, this is what the file is going to look like, almost like this manifest that we call the Py project toml. And everything in here looks good. So do you confirm generation? Yes, I do. At the end of this procedure, if we open up our Explorer here, you'll actually see that a pyproject.toml file got created. And check this thing out. It includes everything that we went through in that wizard. And now our project has been initialized. The very last thing we need to do is to use this pyproject.toml file to install the packages that we talked about. So let me open up my terminal again, and all we got to say is poetry install. And it's going to use the packages that we have in pyproject.toml. Press enter, and you'll see the first thing it does is create a virtual environment, which is really nice. You don't have to manage that or create it yourself or anything. Poetry handles all of it and is installing all of those packages into that virtual environment. And there you go. The project has been created, initialized, and our packages and virtual environment installed. So the last thing we need to do to start writing our tests is to configure VS Code for Python development using PyTest. We'll start by telling VS Code where our interpreter is. This would be the virtual environment that's holding all of our packages and dependencies. From there, we need to create a test folder that also includes this init.py file, and you'll see that here soon. And then we need to configure the tests to say, hey, here's a test folder, and also use PyTest as our testing framework. So let's see what that looks like. I'm going to start things off by getting the path to the virtual environment that Poetry is managing. We do this by saying poetry env info. And you can see there's a whole lot of information that it's gathered. But what we care about is this path right here. So I'm going to double click on this and copy it. From there, we need to open the command palette, which you can go to View, then Command Palette, or in my case, I've set it up to be Control-OP, but View, Command Palette, and then up here, you'll have a bunch of different options. If we search for Select Interpreter, you can see this first option here. This is the one that we want. So select the interpreter. It's going to start the Python extension that we've installed for VS Code, and then we want to enter the interpreter path. Instead of having to find it, we already copied it, so I can just paste it in here and press enter. Notice how in the bottom left corner of my screen, I now see this Python 3.9.1, all this craziness, right? This is the actual virtual environment that Poetry is managing for us. But now VS Code is very much aware of it and is using it for this project. Sweet. So we're done here with my terminal. I'll close this for now. The next thing we'll do is create a tests folder. So let me click this folder here and type in tests, all lowercase. Press enter, and there we go. The one piece we need to make sure is that we got to include the dunder init.py file. And when I say dunder, I mean double underscore. So underscore underscore init underscore underscore .py. And those underscore underscores, by the way, we just say dunder. So this dunder init. And in this file, we don't got to do anything. So just close this and we're fine there. This init file is basically used by VS Code and PyTest just so then it sees this kind of as a package. And I won't dive into that too much, but just know for now that we kind of have to put that in here. If you're using PyCharm, it's smart enough to not need this, but VS Code needs it for now. So just don't worry about it too much. Just include the dunder in it and you should be fine. And oh my gosh, we are so close. All we gotta do now is configure the tests. So let's open that command palette again. And this time I'm going to search configure tests. And here it is, this first option, Python configure tests. Click on this. It's going to ask you which test framework are you using. We are using PyTest. So select PyTest, and then it's going to ask which directory is going to contain your tests. In our case, we have this test directory, so click on that. Oh my gosh, and things are working because look, it says, hey, no tests were discovered. Is that right? That is correct. We don't have any tests yet. But now we can start writing tests. So before we go on to the next video that's going to be all about that, let's write one example test just to make sure everything is working as expected. So underneath tests, let's make a new file, and I'm going to call this one test underscore example.py. Notice how I started the file with the word test. All of your test files by default will need to start with the word test underscore and then whatever you want to call it after that. So in my case, test underscore example.py. So make sure you include that test underscore. That's very important. Same thing with our tests. Our test names will need to start with test underscore as well. And you'll see that right now. So let's write a test real quick. So from Pylenium .driver import Pylenium. Then we'll use def test underscore Google. Notice again the test underscore. And we need to pass in the Pylenium fixture. You can think of the Pylenium fixture as like the actual WebDriver itself. We just call it Py. And now we can use Py in our tests. So Py dot, and here's all the things you can do. Now remember at the beginning I said that Pylenium is a very simple wrapper on top of Selenium that has Cypress-like bindings. So if you're familiar with Cypress, a lot of this is going to look very similar. If not, that's totally okay. You'll get to see it right now. So py.visit is going to navigate you to a URL. And we're going to go to google.com. There we go. And then we're going to perform a search. So py.get, we're going to get the search field, which I believe is the name of Q. And within this, we're going to type the word puppies. Yay, puppies. Who doesn't like puppies? So let's type puppies into the search field. And then from there, we need to find the submit button, because with the submit button, we can actually submit our search. And it has the name BTNK. and then we'll just submit that. There we go. And once we submit that search for puppies, then we should see a page that contains the title of puppies that we just searched for. Right? That would make sense. Save the file. And do you see what I see? Because I see a run test and debug test above my test now. Me seeing this means that everything is now configured correctly on VS Code. It knows that this is a test with PyTest. And so it's identified it once I save the file. And this is really cool because now I can put things like breakpoints, like I'll put a breakpoint here, let's say, and then I can debug the test and it'll stop here and I can step through and do all the regular debugging stuff I'm used to. Or you can just click run test and have it execute the test. And oh, all of a sudden we got this red squiggly. What the heck, Carlos, what happened? Well, the thing is, VS Code is all ready to go, but we haven't actually initialized Pylenium to be ready to go as well. So almost got you there, but let's open up our terminal again. And all we need to do here is initialize Pylenium. Now, normally you would just say Pylenium init, but notice how for me Pylenium is red, right? Because we didn't install Pylenium to my machine, we installed Pylenium to our virtual environment within Poetry. So if I want to run a command within the virtual environment, you start it with poetry run, and then the command you want to execute. In my case, poetry run Pylenium init. Now, before I run this, I want to open up this Explorer here so you can see what we currently have. Right? We have the poetry lock, the pyproject.toml, our settings in VS Code and everything. Now let's execute this command. And more things just got created. So you'll see we now have this pytest.ini file, we have a conftest.py file, and a pylenium.json. This is everything that Pylenium needs to work, to run. If we open up this pylenium.json, we'll actually see some of the stuff that is being used. So for example, here's the default configuration that's running Pylenium. So we'll have our browser of Chrome by default, but you can change this to be other things like Firefox or whatnot, but we won't do that for now. But now that it's all set up and initialized, let's go back to test example and run the test again. And there you go. This time it passed. So now you can see that VS Code, when it passes, it shows little check marks. And when it fails, it shows a red squiggly with the error message as to why it failed as well. And that's just one small example of how we're going to be doing this throughout the rest of the course. So I hope you're as excited as I am, because we're going to get into some cooler stuff, more tests, refactoring things and whatnot. It's going to get pretty awesome. So for now, VS Code set up, Pylenium is set up. You can start writing tests and playing around with it. I'm going to show you a cool resource that you have access to next. Alrighty then, so I want to show you this because I created a whole repo on GitHub that includes all of this code that we're going to be going through. So don't feel like you have to, copy everything from the screen and, oh crap, I didn't see that or forgot that. And you actually have the text form of this whole thing. Now, if you look through here, at the bottom of the README, I've included the commits of every change that is made so you can copy and compare your code. Feel free to pause the video and refer to the repo whenever you need to. Like literally, you'll see everything in here. So hopefully this is a huge help for you because I know that having the code that I can work along with the video has always helped me out. So hopefully it helps you as well. All right, everyone, you should now be ready to start writing UI automated tests, which we'll do in the next video. Hello again. You made it to the third module where we're going to write UI tests using Pylenium and PyTest. Let's jump right in because we're going to code quite a bit. We'll start by taking a look at the demo app we'll be using in this course. It's a simple to-do app with a single view, and this is the URL. Don't worry, I'll include it in the notes below too. For now, the scenarios we want to cover will be checking the first item on the list, checking many items on the list, checking all items on the list, adding a new item to the list, and if we can, remove an item from the list as well. I'll open the website and, sure enough, it's super basic. But the focus of this course isn't so much Python programming or page objects, so this will do just fine. With that, let's write the first test against our app, which is to check the first item. With our project open in VS Code, the first thing I need to do is create a new file. So under tests, let's make one called test-todo.py. Let's put our tests against this to-do app in this file for now. All right, so let's start it off with Pylenium driver, bringing that in. Import Pylenium. All right, and the name of our first test is going to be test check first item. Now that the test signature is done, let's get to the website. And I probably should have copied this because this is kind of a long one, but that's okay. Sample to-do app. Bada bing, bada boom. Okay, next I need to get to the checkbox. And then I need to click the checkbox. I was going to put click it. And then I need to assert that it's checked. So let's work on step 2 here, which is getting the checkbox. Open our developer tools, and I'm going to find this first item checkbox. And here we go on this side. So we see that we have this input, which is the checkbox itself right here, but it's under this li, this list item of ng repeat sample to do, and then also has the span with the name first item. Now, there's a few different ways we can find this actually. We could do it by position, right? We could find all the li elements and say, give me the first item in here. We could also do it by the name of the item. So in this case, it would just be called first item. And I'm going to go with that one because I like the flexibility of finding things by name more so than just position. Especially since I know that in our future scenarios, we will need to find things by name, not really by position. So let's see if we can find that. Anytime you want to work with text of an element, it's usually best to work with XPath. So let's see if we can find this. All right, and here we'll have the text that equals first item, exactly how it's spelled there. And there we go. Sure enough, we found it. So I have it, but the only problem is that I don't think I can actually click on this thing. It's just a span element. So let's find out. If I click this, does it do anything? Nope, nothing changed. So I'm close because I have the span element, but I want its like previous sibling, right? I want this one right here. And so for now, I think what I'll do is just, I can have the parent element, and then, I mean, because that would be the li itself. If I click on that, that probably doesn't work either. Yep, I definitely got to click on the input element. So, which is definitely okay. If we say query selector here, and I just say input, which would be the child, right? And get the input. There it is. And exactly what we want. Click on it, and it got checked. Let's go. So I was able to find it by text, then get its parent, and then from the parent get the input. And again, there's lots and lots of ways of finding this one. You could even use things like previous sibling and whatnot. But for now, I'm going to keep it like this, just so then you can see how this would look like inside of Pylenium. So before I move over, I'm going to copy this XPath because this is exactly what I wanted. I don't have to repeat myself, right? So copy this and let's switch back over to code. Okay, so checking the box. Let's say checkbox is equal to py.getX, which would be XPath. And then I'm just going to paste what I had copied. There we go. From there, we got the parent, and then we got the input. Not too shabby, huh? All right, next up is clicking the checkbox. And so we have it already, checkbox.click. And that's done. Now let's assert that the checkbox should be checked. So assert that the checkbox should be checked. Sweet. And there you have it. The first test is done. So now on to the second one. I'm going to get rid of these comment lines here. They were just helpful for me in my thinking as I was doing stuff. For the next test, it would be test check many items, right? And we'll use the same stuff that we had before. And rut-row, I just realized I have to do the exact same thing. So let me grab this line, come back down here, paste it in there. And now for test check many items, we immediately see duplicated code with the py.visit in both tests, right? But we'll clean that up later. I just want to note it because already we're copying and pasting code, which usually is a sign that we could optimize it a little bit better. But let's keep going. So for checking many items, I think let's just do at least 2 of them. So we already took care of the first item. Let's click on like the second and fourth item, let's say. All right, so let's grab these 2 and check them. Now this is something that where the positions would make sense, right? Because I don't really care about their name. I just care about their position. And so, okay, we'll have to change our strategy here a little bit, not find things by text, but find things by position. So let's see how we can do that. Now in here, I want to grab a list of these things. And fortunately, they're already in a list with these LIs, right? The LI sample to do. So let's see if we can use that. So in this case, I'm going to do $$, which is now a jQuery or CSS selector. And let's find all of the LI elements that have the ng repeat that contains the ng repeat of sample to do. This is something like that. Now there's 5 of these things, which would make sense, right? And if I expand this list here and go through them, 1, 2, 3, 4, and 5. Okay, so if I want to click on the second item here, then we would index 1, right? Because 1 would be the second item. 0 would be the first item. Right on. So we have this. I'm going to copy this and switch back over to our code. So let's start by making a variable. I'm going to call it to-dos. And then I want to not get a single element. I want to find many of them. So py.find and paste in my CSS selector. But we want to grab the to-do number 2 and to-do number 4, right? So to-do 2 and to-do 4. This would be equal to to-dos with the index of 1, right? And then to-dos with the index of 3. Now that we have to-do 2 and to-do 4, we just got to click on each one. So to-do 2 dot click, well, no, because remember, we need to get the input element. And right now we have the li ng repeat thing. And so we say to-do 2 dot get the input and click on that. And then to-do 4 dot get the input and click on that one. All right, and what happens when we click on these 2 things? So if I click on second item and fourth item, this changes, right? It now says 3 of 5 remaining, which makes a whole lot of sense. Could we use this text to actually do our assertion here? Let me inspect it real quick. And yeah, sure enough, there's text saying 3 of 5 remaining. So let me give that a try real quick. Let me switch back over to code here, and let's assert that somewhere on the page it says 3 of 5 remaining. So assert py contains 3 of 5 remaining. And that's it, y'all. How you like them apples? See, it's pretty clear, and the test itself reads really, really well. But even with it looking as nice as it does so far, we do have a few problems actually, right? One of them was that we copied and pasted py.visit. Any new test we add, we're gonna have to do the same thing, right? Which is not ideal. The other thing too is that lines 15 and 16 here, where we did the to-do get input and to-do 4.get input, was a little spicy too, right? So I wonder if we can clean this up. So I'd like to take some time to refactor our tests, since we're going to start repeating ourselves quite a bit. I'm going to have us build something that's going to basically look like a page object, and that's fine. So here, let's create a class that's called to-do-page that's going to represent this page. So def init self pylenium. And this is, you can think of the def init as kind of like a constructor. It's not exactly a constructor, but it's essentially doing the same thing. So if you're familiar with like Java or C#, hopefully this is already making sense for you. But if not, that's a-okay as well. So we're going to initialize the to-do page. You have to pass in the WebDriver, which is Pylenium here. And let's make a function called goTo, which is going to do the py.visit part. So let me grab this part again here and copy all this goodness. So copy right in here. We're going to paste a Ruski. You'll see at the beginning the py is green, and that's because we're inside of a class now. So we have to say self.py.visit. And then I'm going to return self. Now, why return self? Well, the reason why we're returning self is because when I go to the to-do page and use this function goTo, I'm still on the to-do page. There are going to be some functions that when you call them, they take you to a different page. So don't return self, you're on the new page, so return the new page instead, right? You might see this return self in action a little bit later, but for now, just add that in there, make sure you include it. The next method that we have is to get a to-do by name. So let's say get to-do by name. We have self because we're in a class, and then you pass in the name of the to-do and it will find that element. All right, and for this one, we want to return self.py.getX with whatever element we find that has the text that equals that name that you pass in, and then get the parent back. So this is almost looking exactly like what we had in our test, right? Down here we had get the element by this text of first item, but this would only ever work for this element of first item. So this one is a lot more dynamic where we can pass in any name and it will find the element and return the parent. Pretty sweet, right? This is green right now because it has no idea what we're talking about. Element doesn't exist anywhere here in this file. But luckily, VS Code is super smart. We can click on this here and it says, hey, I think you actually want to import element from Pylenium, which is true. So let's do the second one. Add import element from pylenium.element. And it gets automatically imported for us at the top of the file, and the green squiggly goes away. Very nice. On to the next one. Here, we'll write our last method to get all the to-dos that exist on the page. So instead of returning a single element, this is going to be returning a list of elements. And we can basically copy this part that we already did here, because this is what we're wanting, right? Py.find all this goodness. So let me copy that, go back up here, and then return self dot and paste in what I had there. Just like we had before, elements is green and squiggly because it's not up here yet. And so this time I'm just going to add it manually myself. There's elements. And we see that error go away. Now that we've refactored the logic into something a lot more reusable, we got to set up a PyTest fixture, which acts like a hook, which is just before each and after each. So in other frameworks like a JUnit or an NUnit from Java and C#, you have this like after each do this thing, or before each test do this thing. In PyTest, we use the concept of fixtures, which are the exact same thing. It's a single function that works as a before each and an after each. So let's do that right now. At the very top of the file, I'm going to import PyTest. Okay, and then below our to-do, we're going to create a fixture using PyTest, so PyTest.fixture, and in here we create a function that will represent our page. So Pylenium, and then return a new instance of our to-do page after we go to it. So a way to think about it is whenever one of our tests uses this page fixture, it's going to go to the to-do page, which navigates to this URL, and then it's going to return an instance of the to-do page for the test to use. Pretty cool, right? So let's go to our first test here because there's going to be quite a bit of refactoring. Let's grab this Pylenium stuff because we don't actually need this anymore. We just need an instance of our page fixture. And we know that our page fixture returns an instance of to-do page. We don't need this first line of py.visit because we're already on the to-do page once this fixture is done, right? So I don't need that line anymore. For the checkbox, we don't need this py.getX or anything because we already have this line in our to-do page. So I can just say page.getToDo by name. And the one that we want is called first item. But we still right now got to get the input. This line remains the same because we still want to check it. And then we're going to assert that it's checked. So the first test has been refactored and cleaned up. Moving to the second one, we do still need Pylenium, so let's leave that alone, but we can still take advantage of our new page fixture, which is just a to-do page. We don't need this first line like we all know, and this py.find, we don't need either. We can actually just say page.getAllToDos. because that returns, well, all the to-dos. And with that, this one is complete as well. It's looking a whole lot better, but I'm still not liking the part where we got to say like to-do2.getInput. Still not liking that. Let's write one more test and let's get back to it. For the third test, we are checking all items. So check all items. We have Pylenium that we can take advantage of. We also have our page fixture that we can take advantage of. And now all we got to do here is basically create a for loop and just say, okay, for each one of these items on here, I want to click it, click it, click it, click it, click it, right? And then we should see 0, 5 remaining. That's kind of the gist of this test. So we have all the to-dos already, so I don't got to find anything else, right? We did that. So let's create a for loop to handle that logic for us. So for each to-do in page.getAllToDos, to-do.getInput, the part that feels bad, and then we'll click on it. All right, and then from there, we can assert that py.contains config. No, I want py.contains, I said. We want it to be 0 of 5 remaining. And this one is done here too. Okay, in all three tests, we've had to do this .getInput thing because we're dealing with the parent, the li element, and not the input or the checkbox itself. So I think this is a good design decision where what if we had our functions in our to-do page return the input checkbox instead of the parent element? We can do that too. And that might make things look a little bit nicer. So let's go back up here. And instead of this just returning the parent, let's have this actually return the input. So add get input here, that'll take care of that one. And then for our get all to-dos, we just need to say, hey, find the children that are the input. And this one should be taken care of as well. Now we'll go down here. We don't need this get input anymore. So go to these ones over here too. I don't need this. It'll just be to do 2.click and to do 4.click as well. And then down here, just to do .click. Yeah, that looks a whole lot better, don't you think? I like that more. All right, for the fourth scenario, we now want to add a new item. And we kind of have the logic there already, or the to-do page to do this. So let's go back up here. I feel like I'm saying to do like a million times, but let's do this thing. So inside of our class, let's make a new method that's just called add to do. Self, we want to name it something, right? And we're going to return the to-do page just because, again, when we add a to-do, we're still on the to-do page. It's like going back over here to our application. If I add foo and then add the item, we are still on this to-do page. So I'm going to return the to-do page, right? So when we did that, we interacted with two elements. We needed to add one here and we needed to click this as well. So let's find these things. So inspect it. Here's the input. It has the ID of sample to do text. That's very nice. I'm going to copy that and switch back over to code. Okay, so self.py.get. And let's use the hashtag, which means ID of this. And I want to type in whatever name I pass in. We now need to find the add button. Let's inspect this one here, inspect. And oh, sure enough, the ID is add button. That's very convenient. Thank you, Lambda test. So simple. And all right. Self.py.get, the hashtag again for ID. And we're going to click it. Then return self. And bada bing, bada boom, our method for adding a to-do is complete. So it shouldn't be too bad for us to now write a test for this because we have all the pieces we need already. Dev test, add new item. We'll be using Pylenium. We'll also be using our to-do page. First thing we'll do is we're going to add a to-do and let's put it finish the course. Woo! Our first to-do item. And then once we add a to-do, we want to check a few things, right? So once we add this one, one thing that we saw was that, hey, look, the number of remaining went from 5 to 6. So we can actually check that it would say 6 of 6 remaining, and we can also check that there's 6 items in the list, right? 1, 2, 3, 4, 5, and 6. So we can check these two things. We're going to add 2 assertions here. So for the first one, let's say assert page.getAllToDos. This should have the length of 6. For our second assertion, we can say that Py should contain 6 of 6 remaining. And now this one is done. The last scenario we had was to remove an item, but as you saw in the UI, there's not a way for us to remove that item. But I bet that if there was, you would know exactly how to write that test. You would know what to add here to this to-do page class. You'd probably write a method called like def remove to-do by name or remove to-do by position, and then writing the test would be a piece of cake. And this is one of my favorite reasons for using Python, because Python is such a powerful and dynamic language, and you saw how Python, PyTest, and Pylenium, the 3 of them, make such a powerful framework that you get to work in, and writing these tests didn't take much time for us at all. So I hope you enjoyed this. We'll be moving on to the next video, where we'll be running tests in parallel. So I'll see you there. At this point, we have 4 tests written against the to-do app. We've only been running them via the UI, which is great for development and debugging. But in our pipelines, the test will be executed using the PyTest runner, aka the command line with shell scripts and such. However, we have only executed them one by one when we should be running them in parallel. Running tests in parallel greatly reduces execution times, which is crucial for CI/CD. We want fast feedback loops so we can learn and iterate quickly, and a test suite that takes more than 15 minutes starts to feel like an eternity when you're trying to get your pull requests merged so you can work on the next thing. It's up to you as the automation engineer to make sure your tests are designed in such a way that you can execute them in parallel and have short execution times. This is easier said than done, but let's take a look at what we've created so far. Running our tests one by one would take about 10 to 15 seconds, which isn't too bad. However, you're most likely going to be dealing with hundreds or thousands of tests, which would take hours if executed sequentially. Running them sequentially means that you are using one thread for all the tests, which is why only one test is executed at a time, as seen here. When it comes to PyTest, we have a few plugins we can use to achieve parallel execution. Pylenium already includes the PyTest XDist plugin, which runs tests in parallel by distributing each test to its own thread. In other words, each test would run at the same time using its own thread, and the execution time would be closer to 5 seconds. This may not seem like a lot, but when you have hundreds of tests, the time saved adds up quickly. Like I said before, it's up to you to design your tests so they can be executed in parallel. So there are a couple pitfalls you need to avoid to do this. For example, tests should not share data or state. Sharing data and state between tests can have them tripping over each other because they can affect each other's outcome, which is probably not what you want. We call this data management, and it's one of the most difficult pieces of automated solutions. Tests should not be dependent on each other. If test B only works after test A is executed, then you have to run them sequentially, which breaks the whole parallel strategy. Instead, here are some pieces of advice that can help you make sure you have parallel design. Each test has its own instance of a driver. This also extends to most objects, by the way. Tests should be independent of each other. We talked about this already, but it's one of the most important pieces of parallel design. Tests should manage their own data and state. Each test should have its own setup hooks and then cleanup hooks once it's complete. Tests should be modular, meaning that they should be small and try to test a single thing. Remember, this is good general advice, but do it make sense for you and your context. There's lots to think about, which may seem a little daunting, but luckily Pylenium is parallel first. This means that it's designed to run tests in parallel. For example, just using the Py fixture already gives a unique driver to each test. Also, parallel plugins are already included when you install Pylenium, since it comes with PyTest and the PyTest XDist plugin already. The base command just starts with PyTest. Then you include any options followed by the file or directory of tests you want to run. If you ran PyTest by itself with no options or arguments, it would just run all the tests that exist in the current project. To run all the tests in our test-to-do.py file, the command would look like this. To run those same tests in parallel, you include -n, which means number of threads, followed by the number of tests to execute at the same time. In this example, run 2 tests at a time. Let's switch to VS Code now so we can see this in action. So here we are inside of our test-to-do.py file. I'm going to open a terminal. And remember, the command we need to run is PyTest plus some options in the directory, right? But because I'm using poetry, I'm going to say poetry run PyTest. And then specify the folder I want to execute. In this case, our test_to-do.py file. If I execute this command by pressing enter, it's going to run all the tests sequentially, one at a time. So let's see how long it takes. Excellent, they all passed, and it took about 12 seconds. Let's try the same command, but this time let's run it in parallel. Now, your machine can probably handle 2, 3, or 4 threads at the same time, so let's do 2 for now and see what happens. Sweet, running 2 at a time took about 7 seconds. Let's try 4 now and see if we can get down to even less than that. Here we go. Woo, we got down to 5 seconds. Hey, that's pretty good. But notice how we went like in half, right? Running all of them sequentially took about 12 seconds. Running all 4 of them at the same time took 5 seconds. So immediately you can see the benefit of running them in parallel. And like I said before, we didn't have to make any changes to our tests. We just added the -n with the number of threads we wanted to execute. That's the power of Pylenium for you, but also PyTest and the PyTest XDist plugin. For reference, I've also included an example of a shared global driver in the test shared driver.py file. You don't need to copy the code into your project. It's just meant as an example of what not to do, so you can play around with it if you like. I included some of the tidbits here with some emojis, as you can see, but also you can see that we have what looks very similar to what we had before with our to-do page, but the big difference is that we're using the shared global driver and the single page object that's shared now between all of our tests. Feel free to try this code out, of course, but some of the things you're going to realize, for example, is that the driver is not inside of a fixture. So when the test is complete, the browser isn't going to close. You'll also see some other side effects, I'm sure, but just take a look at it, play around with it if you like, and make sure to avoid sharing drivers, sharing page objects, and sharing data between your tests. Although running tests in parallel is considered mandatory in a lot of frameworks, you'll quickly realize that your machine is limited and can only handle so many tests at a time. Eventually, you will need to scale your compute power so you can run more tests in parallel, especially as your automated suite grows. There are many solutions out there, but Lambda Test happens to include scaling in their cloud solution as well, which brings us to the final module, cross-browser testing with Lambda Test. Huzzah! You made it to the final module in this course, where we're going to be talking about cross-browser testing with Lambda Test. Before we get started, I want to quickly overview the steps we're going to be taking in this module because there's a lot we're going to be doing. So the first thing we're going to do is create a Lambda Test account. This is completely free, so no worries there. The second thing we're going to do is connect the driver, aka our framework, to Lambda Test. Now, I will be using environment variables to store my secrets, which will include like my API key. So I recommend you pause the video if you need to know how to do that for your specific OS and shell. For example, I'm using a Mac with Z shell. So doing it that way will be unique. It'll be different from, let's say, like a Windows machine. So make sure you know how to set environment variables. Moving on, we will then run our automated tests and see the results in the Lambda Test UI. Then we'll actually achieve cross-browser testing, where you'll see how we can change the browsers in our framework and then see those different browsers get executed in Lambda Test. Pretty cool stuff. We'll then have different tests targeting different browsers. So we'll have like test A target Chrome and test B target like Safari. And you'll see how you can have each test specifically target different browsers and different OSs. Finally, we will complete the module by running one test that is targeting multiple browsers. So we could have one test that's targeting Chrome and the same test run again, but this time targeting Firefox. So here you see the 6 things we're going to be going through in this module. I hope you're as excited as I am because we're jumping into step number 1. Let's create a free Lambda test account. Okay, I navigated to lambdatest.com, and here, just in the top right corner, you'll have an option to create an account or log in. I don't think you need help creating the account, so I'm going to skip past that real quick and move on right to when you land after creating the account. Here we are. Now, hopefully the creation was easy for you, but you'll eventually land on a page that looks like this. If it's your first time logging into Lambda test, you'll probably go through like this small tutorial or small wizard, but there will be an option for you to just click Get Started. Once you click on that, it's going to show you a bunch of information, including your access token. You're going to need this access token, so I highly recommend you copy it. Now for me, mine is blurred here because this is something you do not want to share. So make sure you copy it, but do not put this in your repo and upload it to the cloud. That's very dangerous. So please take care of your secrets. So let's work on connecting our driver or our framework to Lambda tests now that we have the account created. Step 1 is to copy this access token so you have access to it now. And then we're going to set it as an environment variable. Remember, this is the part of the video that I recommend you pause and go search how to set environment variables for your specific machine and setup. I have a Mac using Z Shell, and so there's a very specific way we do that here. I'm going to use the Vim editor and open my ZSHRC file. There looks like a lot going on here, but all I need to do is add 2 new environment variables. And I'm going to give them very specific names so I know what I'm working with. Right here on line 58 and 59 is where I'm going to set my environment variables. I use the export keyword to make sure that it's public to my machine, and then I'll call my first variable lt_username in all caps and set that to my username for Lambda test. The second variable is called lt_access_key with my access key that I copied from my Lambda test account. Now that I have these environment variables set, I can close the file and then source the file to complete it. And that's it. Now I can use it in my code. The next thing you'll want to do is to copy the capabilities object that exists on this right-hand side for you. Like I said, for me, I don't have it because I've already used my Lambda test account, but when it's your first time, you'll see what I'm talking about. It looks like a code snippet for Python over here on the right. Another way of finding that would be to go to the Automation tab here, clicking Help, and then you have the capability generator right here as well as other helpful documentation and whatnot for different types of languages, frameworks, and whatnot. So let's click Capability Generator, and it takes you to a view where you're actually able to use different languages. In our case, we want Python, and it'll show you what we need to copy into our framework. The cool thing about this is that you can change the different types of OSs that you want. So here's like Mac OS Catalina. You'll see that the capabilities object changed on the right-hand side. If we want to target a different browser, let's say like Safari, then it'd look like this over here instead. So you can actually use this capabilities generator. So then you don't have to go struggling and finding out what you need to do. Let Lambda test build this for you, and then you can just copy this capabilities object. So for now, I'm going to switch this back to be Windows 10, and let's have the browser be Chrome. That's fine. The version is the latest one, which is 89, and the resolution is good too. Perfect. So I'm going to copy this capabilities object. Back in VS Code, in our test2do.py file, I want to show you how to create a PyTest fixture for Lambda test using just Selenium, because it is different from how we would do it in Pylenium. The first thing we need to do is import OS. Then From Selenium, we'll import WebDriver. All right, and now it's time for us to create our PyTest fixture. So let's make some space here at pytest.fixture. And I'm just going to call this one Selenium, so it's really easy to know which one this is. Let's bring this up here for a little bit of room. Now, step 1 is to define the 3 pieces we need to connect to Lambda test. That would be our username, access key, and the remote URL to connect to our instance of Lambda test. So username is equal to os.getEnv, and in my ZSHRC file, I called this environment variable lt_username. The next one is the access key, os.getEnv, and I called this one lt access key, just like that. Then for the remote URL, you should have seen this in that starting page as well. What we have here, we're going to put the username and access key into those spots at hub.lambdatest.com/wd/hub. And then let's put these in here. We had our username into the first position and our access key into the second position. And there we go. Step 2 is then to define the desired capabilities for this specific test run. This is where we're going to paste in the capabilities object that we copied. So just to follow the code snippet that they provide, I'm going to call this desired caps and then paste in what I copied. We can then change the build to have a different name. We can call this one like the Selenium example. Let's call the name of our test run Selenium example run. And we can leave the platform, browser name, and version alone. Now you may have some other stuff as well. Like for example, you may have resolution, which we had at 1024 by 768. But notice how you can change these as you need. And then we're going to get this desired caps. And for step 3, we'll instantiate the new remote WebDriver that is connected to Lambda test. So this is where we're going to actually make the driver, right? So WebDriver.remote, since we're connecting to a remote instance, we have the command executor, which is going to connect to our remote URL. And then for the desired capabilities, we called this object desired caps. And look at that, we now have a WebDriver that's connected to Lambda test. So any test that uses this Selenium fixture is going to be using this driver. And just to make sure we have everything wrapped correctly, the very last thing we need to do is yield the driver so the test can use it. So that would be yield driver, and then when the test is done, driver.quit. And there you have it. That is what the fixture would look like if you were just using Selenium, not Pylenium. Also, remember that this code is available on the GitHub repo that I provided at the beginning of the course, just in case you want to look over it again in more detail. For now, I'm going to copy this object again, just because I added the resolution bit. So I'm going to copy that. And now I'm going to show you how we do the same thing, but instead of creating our own fixture because we were using Selenium, we're going to do this with Pylenium, and you're going to see it's a little bit different. With Pylenium, we achieve this by using the pylenium.json. Inside of here, we have this capabilities object with nothing inside for now. So all we got to do is replace it with what I copied before. And that's basically it. Now, we're going to make some changes here just because we would have already completed it, and you can see just how easy it was for us to do it in Pylenium. But the next thing I want to show you is creating a shell script that your pipelines will most likely use. So we're going to be running this example here soon. So let's change the name of this build. Let's call this PyTest build. And for the name, let's do PyTest tutorial. How about that? So in our Explorer, let's make a new folder, and let's call this one just CI. Nice and easy CI. And within this folder, let's make a new file, and let's call this run lambdatest.sh for shell. Now I'm going to just paste this in so then we can talk about the different pieces rather than seeing me type a whole bunch. So real quick, the first thing that we're doing on line 1 here is making sure that we're saying this is a bash type of shell file. Next on line 3, I'm just telling you here's the flow that we're taking. Step 1 is define the remote URL for lambda test, just like we did in the Selenium fixture. So my remote URL is equal to this right here. It should look really familiar because we've done this already. The username is going to go in the left spot, and the access key is going to go in the right spot. This $sign is us accessing the environment variables that we have set on our machine already. Pretty slick, huh? For step 2, we're going to then define the PyTest command to execute. Now this can include a whole bunch of stuff like filters, config settings, if-else conditionals, and a whole bunch more. But we're not going to be covering that in this course. Really what I want to show you is that we can filter really anything that we would like to run. So in this case, our current filter is going to be running the test-to-do.py file, but also with the -k of check first item. So -k reads, run all tests in test-to-do.py that contain the name check first item. In our example, we only have one test with that name, and so it's only going to run that single test. But you can change and override this as you need. The very last thing we're doing here is then executing that command. So Python-m PyTest, use the filter, and then target this remote URL, which is going to run the test suite against lambda test. So now that we have this, let's open up a terminal and let's give it a try. Poetry run ci/run lambdatest.sh. Press enter. And I get an error. It says here permission denied. If you get a permission denied error, that probably means you're running on a Unix machine of some kind, but you just need to update the permissions by running chmod +x on that file. Then try running the shell file again, and it should work now. Perfect. You can see that our one test passed, and our -k filter deselected our 3 other tests. Let's go back to our lambda test dashboard to see what's changed now that we've executed a test. I have a lot going on right now just because I've been running tests already, but you should see a single one that says PyTest build, right? And it'll say run tests in X amount of seconds. So let's click on this and let's check it out, because now we're going to be looking at the lambda test UI. And whoa, check all of this information out. Some things to be looking out for, because I know there's a whole lot right now. Tests run against a specific build. The build value is most likely dynamic in your CI pipeline, so it's a good one to update using your tool's environment variables so you can dynamically change the build your framework is targeting. You can see how long this test took. The duration is 4 seconds. You also see it was against Windows 10 against Chrome version 89, and also that it passed. You even get a video recording of what the test did, so that way you have artifacts and records of everything that's happening. You also have timestamps, dates, exceptions if they were thrown, commands, networks, logs that were executed as well, so you can see everything that was captured. You can filter these. You can create issues, so there's an issue that you wanted to report. There is seriously a whole bunch of information available to you out of the box that we didn't build at all. It's just part of what you get with Lambda Test. So I highly recommend you take some time to explore all of the functionality that is available to you. All right, Carlos, but what about cross-browser testing? We used Windows 10 with Chrome version 89, but now I want to target something else, let's say like Edge on Mac OS. So let's give that a try next. I'm going to be opening the real-time testing page, and you'll see a whole bunch that you can configure. Real-time testing allows you to spin up your application using any of the configured browsers or mobile devices in, well, real time. However, the reason I'm showing you this is because you can use any of these settings and configurations in your automation as well. So I said I wanted to test against Edge. Let's do version 85 against Mac OS Sierra. And for kicks and giggles, let's change the resolution to like 1920 by 1080. Well, there you go. I mean, look how easy it was for us to be able to pick which versions of all these things we wanted to do, right? All we got to do now is update this in our pylenium.json. So let's do that next. So back in pylenium.json, I'm going to change this to say PyTest build 2, just so we see a different test run in our dashboard. I'll keep the name the same, but for platform, let's change this to say Mac OS Sierra, exactly how it showed in the UI. For the browser name, let's do Edge. For the version, we have 85. And lastly, for our resolution, we had 1920 by 1080. Good thing I remembered that, dang. Save the file, and let's give this a try. So open up a terminal again and run that same command. Let's see what we get. All right, PyTest build 2 finished for me. So let me click on the build here. And there you go, look, we're on a Mac with Edge version 85. Isn't that super awesome? I mean, we just changed a few things around and bada bing, bada boom, we got, a new browser going. So it's pretty impressive stuff. But now let's turn it up just a tad and let's see if we can run different tests with different browsers. Because right now, anything that's inside of pylenium.json is configured globally for the entire project. So all of our tests are going to be targeting Mac OS Sierra with version 85 of Edge. But what if we want different tests to target different browsers? Let's check that out next. Okay, in VS Code, let's go to our test directory. Let's make a new file. And let's call this one test_cross_browser.py. We'll write the new stuff in here. Now, I'm just going to copy and paste again for simplicity's sake. So it's not just me typing the same stuff over again. I'm creating a function here called search, which is just going to do our Google search that we saw before. Right? The only difference really is that instead of me hard coding a search of puppies, we can search any query and we should return, did I land on that query page or not? So that's all I've done here so far is create that function. So now let's write our first test here. So def test Google search in Chrome. And we're going to need our Pylenium fixture. And for this test, let's say the target browser is gonna be the platform of Windows 10. Let's have the browser be Chrome. Let's do version 85. And lastly, the resolution. Let's have this be the 1280 by 1024. So, if you remember, our pylenium.json currently has everything targeting macOS Sierra and Edge. So all of our tests are going to be run against this target. But for this test, we want this one to be different. All of our other tests will run on macOS Sierra versus Edge. This test should not. It should run against Windows 10 Chrome. So just for this test, we need to update the Pylenium config to use this new target. And that's actually pretty easy to do. You just say py.config. We have the driver capabilities, and I want to update it with the new target. Hopefully that reads okay. I mean, py.config.driver.capabilities. I want to update it with the target. But that by itself will now change this test to only target Windows 10 and Chrome. So the last thing we got to do is just run our function, right? Let's search our puppies again. And the test is complete. All right, but let's get the same test and do Firefox this time. So let me copy all this again. So copy this. Let's go under here. Paste to Ruski. But now let's change this from Chrome to say Firefox. And then let's leave Windows 10. That's fine. And let's change this to say Firefox as well. Let's have the version be 81. And the resolution can stay the same. We still need to update the driver capabilities, and we'll still search for puppies again, but this time against Firefox. Okay, I'll save this file. In our pylenium.json file, I'm going to switch this from PyTest build 2 to PyTest build 3. Again, just so we can see the different builds inside of the Lambda test dashboard. And the last thing I want to change now is our CI code. Instead of running all of this, I want to run my test cross browser.py. And since we want to run 2 tests now, I'm also going to include our -n2 to run both of them at the same time. Save this file, and I think we're ready to run the test. So open up a terminal and let's run poetry run ci/run lambda-test.sh. All right, and what does this look like in our automation dashboard now? I have 3 tests because I had to rerun the Firefox test 1 time because I had a small error, but you should see 2 tests. One that says test Google search in Chrome and one that says test Google search in Firefox with the same Windows 10, but different browsers and versions. And oh my goodness, it's a thing of beauty. Here's our Firefox run, searching for puppies. And it's beautiful. All right, we're in the last part of this module, y'all. You may have instances where you would like one test to run against multiple browsers. This is done using PyTest Parameterized feature. So let's check this out, and then we'll wrap it up, y'all. We're so close. Okay, so let's make a new test file just so then this thing is all by its lonesome. In our test directory, make a new file. And to be super explicit, we're going to call this one test1 test against many browsers. Oh my gosh, .py. So we know exactly what this test file is for. And like I did in the last section, I'm just going to paste all this in so we can talk about the good stuff instead of seeing me type a whole bunch of stuff. For now, you can ignore these green squigglies because it's just a small issue I'm having with VS Code as I'm recording this, but it shouldn't affect how I run the tests. So starting things off, line 1 and 2, we're importing the stuff we need, which would be PyTest and Pylenium. Then on line 5, this is our search function from the last example that we had, so you should know exactly what that's doing. The new part here would be these browser targets. Notice how it is a list of 2 different targets we have. The first target would be this right here. This is our Windows 10 Chrome instance with version 85. The second object here, the second target, would be for Windows 10 Firefox. So using the same example we had in the last section, but now we're going to do something a little bit different. Because the last section we had 2 tests, each test with their own target. This time we're going to write one test that will be used to test against both of these browser targets. Very interesting. So let's see how we do that with that parameterized feature I was talking about. So to start us off, we're going to make our test. Def test Google search. We need Py just like we always do. There we go. We're then going to want to update this just like we did before. So driver capabilities, update, but then we got to put the target here somewhere, right? Or the browser. We got to pass that in here, but how do we do that? We'll see here soon. The very last step of the test is then to insert search Py and our puppies. So hopefully everything is looking very similar to what we had before, but the last thing that's missing is passing in our list of browser targets into our test function. At pytest.mark.parameterize, we're going to call each one of these objects just a browser. And this is going to be from the browser targets object right above, right? So right here. Beautiful. And the very last thing is to now pass in browser to our test. And what? The squigglies are gone and the test is complete. So let me walk through this one last time because it looks really simple if you're just looking at this thing on paper, but the concept is really, really powerful. So line 28 is how PyTest is marking this test function to be parameterized. This parameterized function asks for 2 things. It wants to know what the targets are, or what the list of things you want to parameterize are. In this case, we have a browser targets list with 2 browser objects. The next thing here is, what do you want to call these objects? We're going to call each one of these a browser. We could also call it a target or desired capabilities or whatever you want there. I'm calling it just browser just for simplicity's sake. But there you go, we call it browser. The next thing we need to do is in our signature of the test function, we have Pylenium, which is a fixture, but then browser, which is going to act as one of these browsers every time the test is executed. Wait, what? Every time the test is executed? Think about it this way. This is one test function, a single test function. However, it is two separate test cases. Why? Because there are two separate browser targets. So if I were to run this test sequentially, what would happen is that the first time the test goes through, the first browser is Windows 10 Chrome. And so it's going to load in Windows 10 Chrome in the browser, update the capabilities, and then search puppies against the Windows 10 Chrome browser. Then it's going to execute the test again a second time for the second test case, which is the same test, searching for puppies, but this time updating with this browser, which is Windows 10 with Firefox. So again, it's a single test function, but two separate test cases. This means that we can run these two test cases in parallel, which is where things get pretty insane, but that's just the power of PyTest. So let's wrap this up so you can see exactly what I'm talking about. First things first, in pylenium.json, I'm going to replace this to a 4 and save this file. Then in run lambda test, I don't know why I did this to myself. Why did I name it so long? Because now I'm regretting it. Test one test against many browsers. Man, I should have made that not so long. Why didn't you tell me, people that are watching? Save the file here as well. And then let's run this thing. Poetry run ci/run lambda test.sh. Let's see what we get. And here it is. Sure enough, we have one test called test Google search, and yet it ran it as two completely different test cases. Test Google search against browser 0, which was Chrome, and test Google search against browser 1, which was Firefox. So that's how you can have a single test function targeting multiple browsers. And that's just a simple example. You can now start taking these things to even bigger problems that you're facing and run multiple suites against multiple variations and do this full, more powerful cross-browser testing with Lambda test. Well, folks, that's it. We're done with the course. I hope you enjoyed it as much as I enjoyed making it, and I hope you learned something new. Please reach out to me on Twitter or LinkedIn at Carlos Kidman, but I'd also appreciate you liking and sharing these videos or giving me feedback as well. Remember, you have awesome resources all around you, like Lambda Test Community. But thanks for your time, and best of luck to you on your journey with testing and automation. As always, please post any questions in the comments below or at community.lambdatest.com.